January 2007, question 1. This is a groups question. I'm just going to put the question up on the screen to have a look at. So, this question asks us, it says, show that the set of numbers 3, 5, 7 under multiplication modulo 8 does not form a group. Well, that's quite a good start to a question because if we're going to prove a negative, that will be easier. All we'll need to do is find some sort of exception for it. Then it's going to ask us, the set of numbers 3, 5, 7a under multiplication modulo 8 forms a group. Write down the value of a. That is a nice little clue to how we're going to solve that one. We'll come back to that in a minute. Then it says, state, justifying your answer, whether or not the group in part 2 is isomorphic to the multiplicative group r squared r cubed, where e is the identity and r to the power 4 equals e. So a little cyclic group. Right, let's get on and do this question then. Now, the first part of the question asked us to show that the set of numbers under multiplication modulo 8 does not form a group. Now, multiplication modulo 8 means that we're going to multiply the numbers together and then find their remainder when you divide by 8. So I'm just going to start a little group table here, and we're going to, because the easiest way to prove that something's not a group is often to show that it's not closed. Now, 3 times 3 would normally be 9, but under modulo 8 that gets us 1, and bingo. 1's not one of our numbers, this group is not closed, so it's not closed, and so it's not a group. Now we had a little clue in that because in part 2, in a minute, they're going to want us to tell us what letter A represents, which gives us a hint that there was something missing. So, not a group. So, we've done part 1. So, part 2, now, they want us to actually show, they want us to say what A is. We've got these letters, we've got A, 3, 5, and 7. And A, 3, 5, 7. Now, they said write down the value of A. Well, it's a pretty good guess that it's going to be 1, but I think it's going to be useful for part 3 if we actually write out this group table, because I think we're going to need to use it then. So, in here, if we suppose that A is 1, so I'm going to change that to 1, and we're going to see whether this group table works. So 1 times 1 is 1, then 3 and 5 and 7. So 1, as you expect under multiplication, is the identity. Now, 3 3's are 9, which gives us 1 under modulo 8. 3 5's 15, which is 7 under modulo 8. And then 3 7's 21, which is going to be 5 modulo 8. Then 5 3's, well, we've done 3 5's, so that's going to be the same there. And that one's going to be 5, and I'm going to start filling this in largely through the fact it's a Latin square. But 5 5's would normally be 25, but that's 1 modulo 8. So that one's got to be 3, that one's got to be 3, and that one's got to be 1. So, another interesting little point here is that the identity runs all the way down the diagonal. So 3 squared is 1, 5 squared is 1, 7 squared is 1. We'll see how that's useful in part 3 in a minute. But we better write the answer down because they did ask us to state what it was. So A equals 1. Now, part 3 asked us to show, let's have a quick look at it again. Part 3 asked us to show that, or to state, justifying our answer, whether or not the group in part 2 is isomorphic to the multiplicative group r squared r cubed. This is a cyclic group. It's all built up of powers of r, and r to the power 4 is e. Now, first thing, normally we will be showing that a group was isomorphic to another group by producing a mapping between the two groups and showing how each element mapped to the other element and how the mapping of A blob B is equal to mapping of A blob to the mapping of B. That's quite a lot of work. Luckily, we don't need to do that here because, and I'm going to write this down so remember it. So a cyclic group is only isomorphic to another cyclic group because the structures of the group have to be the same. You can't have a cyclic group isomorphic to one that isn't. Now, and we've got r squared r cubed is cyclic our group above 1, 3, 5, 7 is not, because 1 squared equals 1, obviously, 3 squared equals 1, 5 squared equals 1, and 7 squared equals 1. So we can say quite clearly that they are not isomorphic. And that is that question done.